How are you listening to this music right now? Well, you might know that your speakers are creating sound and your ears are listening to it. But there's a lot more going on over here. You see, all your speakers are doing right now is vibrating the particles of the air close to it. Then they vibrate the air molecules close to them, and so on and so forth. And we call this a sound wave. And eventually, when the air molecules close to your ears start vibrating, we hear sound. But how does something as boring as air molecules going back and forth make us experience something like this? Well, for that, we need to look at our ear carefully. I mean the entire structure of the ear. So let's look at how the different parts of the ear work together to make us experience sound. So our ear can be divided into three parts: the outer ear, the middle ear, and the inner ear. The outer ear starts with the pinna. It's the part that you can see and touch, or in my case, the part that my mom would twist quite often. Its job is to collect as much sound waves as possible and channel it into the auditory canal. The sound waves pass through the auditory canal and eventually meet the eardrum, which is shown in green over here. The eardrum is a transparent membrane which is super sensitive to the vibrations of the air. So as the air vibrates, even the eardrum starts vibrating, just like the skin of a drum. And as you can see, the eardrum also separates the outer ear from the middle ear. This brings us to the middle ear. The middle ear consists of the three tiniest bones of the human body, and they're together called the ossicles. And they have pretty cool names. They're called the malleus, the incus, and stapes. And here's the actual picture of these three bones. And because of their shapes, they're also commonly called as the hammer, the anvil, and the stirrup. Stirrup is where you rest your feet when you're riding your horse. Alright, so as the eardrum vibrates, you can see the ossicles also start vibrating, transferring the vibrations from the eardrums to the inner ear. Now their main job is to increase or amplify the pressure of the sound waves when it reaches the inner ear. But why do we need to increase the pressure of the sound waves? Because as we will see, the inner ear consists of a liquid, not air. So the vibrations must transfer into a liquid. And you might already know that vibrating or moving particles of liquid is much harder than moving particles of air, which is why it's very easy for you to swing your arms in the air, but it's pretty difficult to do that inside water, like say in a swimming pool. And so to set this liquid in vibration, the pressure has to be high enough. And in fact, it turns out that our ossicles increase the pressure of the sound about 20 times. But how do they do that? Well, just take a look at the base of the stapes. It has such a small area compared to that of the eardrum. So when the force gets transmitted from the eardrum to the stapes, it gets concentrated in a very tiny area. And you might know when you concentrate force in a very tiny area, you increase its pressure. And that brings us to the inner ear. The inner ear consists of a bony structure, which is shown in purple. Now, as you can see, the top part of this structure consists of three semicircular rings. They help us in maintaining our balance when walking or dancing or whatever we do. So they're not involved in hearing, so not so important for us. The part that's involved in hearing is this snail-like structure. This is called the cochlea. What does it do? Well, although these bones have already started dancing to the music, nothing gets heard until these vibrations are converted to electricity and sent to our brain. And that's exactly what the cochlea does. Now, the cochlea is super complex, and it's also a little mysterious. Even today, there are certain things about it we just don't know. And so we'll definitely not go into the details. But as mentioned earlier, it contains a liquid. And when the stirrup hits our cochlea, this liquid starts vibrating. And then there are some specialized cells in the cochlea that convert these vibrations into electrical signals. And these electrical signals go through the auditory nerves all the way to your brain, where it gets finally interpreted as sound. And the cells of your cochlea are amazing. The electrical impulses that they generate are super sensitive to how loud the sound is or how feeble the sound is, whether it is high frequency or low frequency. And as a result, your brain can differentiate the tiniest differences in the sound. And so you can understand different letters or words, or even understand what I'm saying right now, or hear the different notes of this music. And so, to summarize, the outer ear collects the sound waves through the pinna and directs them to the eardrums. The three ossicle bones of the middle ear amplify these sound waves, transferring it into the cochlea, and the cochlea converts the back and forth vibrations of the particles into electrical signals and sends it to our brain. And regardless of how many words are used to describe what's going on, the very fact that the back and forth movement of the air can be converted into this amazing experience we call sound is truly unfathomable and beyond words.